In this episode of the AWS Developers Podcast, we're talking about Valkey GLIDE, a client-side library to access Valkey, but we'll explain that in a moment. Stay tuned. Good morning. Thank you for downloading the AWS Developers Podcast. We're available every Friday morning in all good podcast applications. Thank you for subscribing. Thank you for sharing the podcast and leave us feedback so that we know what type of content is important for you. Today, we're going to talk about Elastic Cache or a specific version of Elastic Cache called Valkey. Valkey is actually an open source project. It might seem confusing like that with my words, but it will be much more clear when Avi will explain that to us. Avi Fenesh, your SDE in the Elastic Cache team. Thank you for being here. Maybe first, very high level question. What is Valkey?
Okay, so we start. It's high level question, but it's the hard question. So, so everybody know where Redis.
Redis, an in-memory database, key value used for cache. Can summarize it like that?
Yeah,
it used to be.
Cache is just cache is just one usage of this product. Yes, there is many more stuff to do with it. But yes, Redis was the standard in the industry. Mm-hmm. Everybody knew it. It was amazing because it was open source and the community was involved and everything.
And then boom.
Yeah, and then the drama 1 year ago started, and Redis. Without getting into legal information, basically it's not open source anymore. They decided to change the license, and it's not open source as we see open source and free software. This was a big drama because the community were very involved in the development of Redis. One of like Elastic Cache team, my team had developer that their job is basically to
contribute to the open source project.
One of the 5, there is the core team in project, open source project. Normally there is some governance models. So the governance model of Redis was 5 team member of the core team, and one of them is Madeline, which is a developer from Elastic Cache, and this was her job in Elastic Cache, meaning like also us as Elastic Cache were strongly involved, and suddenly we can't use it anymore. It's not open source as we see it.
But this is where the open source community stand up and decide to fork. Forking is a bit like a nuclear weapon in open source world. But they fork the project and put the project under the lead of the Linux Foundation.
Exactly. So Madeline, the same developer that I mentioned, very fast decided to take the initiative and fork it. So this is something that happened a lot when somebody close source a product. But the Valkey is a sensation in this phenomena because I think I checked the stats and it's the highest growing fork that ever been, except maybe Node.js. So they fork it, and many major big companies, most of the community of Redis, of the contributor, after a fraction of which fork gonna be the main fork, went with Valkey. And right now, I think it's disrespectful even to say a fork because it's a completely different product. It's a completely different product, not in a sense that is not compatible. It's still compatible. If you use Redis, you can move to Valkey without any problem.
Because it's a drop-in replacement. At the time of the fork, we can install one or the other, and everything works. It's the same code base, at least at the moment of the fork.
Yeah. So if you're using until 7.2, which is the last open source version of Redis, you can just move to Valkey with no problem. After that, we don't follow the code, so I cannot say. But Valkey just became more and more and more and more and more improvement. Now we have Valkey 8.1. I did some benchmarking and the results were amazing. There is a new feature and new stuff, and I think we can say that it's not a fork. It's just a new,
It's the
better product.
evolution.
Yeah,
Yeah,
it's
maybe
the evolution. Yeah,
what
exactly.
Redis would have become if it was still open source.
Yeah.
But we are not here today to talk about Valkey, or not directly, but it
Yeah,
was important
exactly.
to give the context. We're going to talk about Valkey GLIDE, which is a client library that allows application developer like you listening to us to access Valkey on the server, and the server might be on your laptop, might be your server, it might be Elastic Cache on AWS, but it's any installation, any instance of Valkey. I have white hair, so I would say it's a driver, Valkey GLIDE, because I remember the ODBC driver or JDBC driver from 20 years ago. We are still using them today. How would you qualify Valkey GLIDE?
So we say client.
A client?
That's
client library?
Yeah, client library. But okay, this is me, but I think it's another arm of Valkey, in a way that it's not just a connector, not just a client, but it completes the product. It's complete the product by taking advantage of everything we can take advantage of on the client side, and we make the whole usage of the product of Valkey much better usage.
So it's developed with developer friendliness, developer experience in mind. That's your objective. Did it exist already at the time of Redis, or is it something new that appeared with Valkey?
So about that, the project started as when Valkey wasn't yet in the air. The project started because my team in Elasticache, along with other responsibilities, we are the client team. Meaning, if you're a customer of Elasticache and you have a problem with your client setup, we are coming, intervening, and helping you solve the problem. A lot of time it means that we contribute fixes to the existing clients. Sometimes we find workarounds for you, but unfortunately, sometimes it is how the client built and we cannot solve it because that's mean to rewrite the whole client. So after we had a few years of experience doing that again and again and again, and solving and contributing and sometimes getting into the point that we cannot do anything but tell you switch client, we decided that we need something better. We need to take this all knowledge. We know all the real pain. We know when crises happen and the business crash because of the client. And we need to create something that the user even don't need to think about how they're gonna mitigate the problem. We're gonna create something with all the knowledge that we have of years of dealing with it, and we create the best of the best, and you will get something that it's pre-designed with all this knowledge. And then it was the initiation of the idea of Valkey GLIDE.
When you say we, just to be clear, it's an AWS initiative to create Valkey GLIDE, the new Redis client, Valkey client, but it's developed in open source and now backed by the community as well. It's not only an AWS thing.
Yeah, right. So that's actually a very important point. It started in-house, but always was intended to be open source project. It was at the beginning under AWS open source like organization, but now it's under Valkey.io, which is under Linux Foundation. It's completely open source. Linux Foundation known being very strict about what open source mean. And there is a very strong involvement. I would say the main team that developed the client is my team, AWS team, but there is also a team of GCP involved, which developed the Go team.
Google. Mhm.
Yeah, but when you listen to this episode, might be already generally available. Depend on the timing. Right now, it's a public preview, and a lot of community, great, amazing community involved in this project. It's completely open source, completely community friendly.
Driven.
We love it, and if you want to join, just drop me a message. Any hour,
So,
I'm there for you. Yes.
so wherever is your Valkey server on AWS, on Google Cloud, on-prem, you can use that client library. But this library, is it also, or this client library, is it also a drop-in replacement for the old Redis client, or is it totally new in terms of developer-facing API? I mean, if I start to use that library, do I need to change my existing code or not?
Okay, so I will give a bit of background before I answer this question, which is an important question. But as a background, Valkey GLIDE is not one client. Valkey GLIDE is written in Rust in the core, which most of the logic is there. It does the heavy lifting. It gives the reliability, the stability, the memory safety, the performance, everything.
So, for example, the connection management, the retry,
exactly,
the pooling, all that is in the core implemented in Rust.
Exactly. And to this, we build bindings
for different programming language.
Yes. So right now we have support for Node.js, TypeScript, ECMAScript, CommonJS, all the standards. We support them. You can use it. We have Python. We have the async.io. We have right now we're merging the NEIO trio, and we're gonna have sync. Maybe when you listen to it, there is also sync. There is Java with example to how to use with Scala and all the other framework of
JVM based language.
Exactly. And there is Go, which is in public preview, maybe already GA. And the main effort right now is on .NET, C#, which I believe will be amazing, and I'm very hope will be amazing.
That's the first. I don't know any driver or client which is made of a common code in one language, Rust in that case, and then just bindings in different programming language. Usually the database clients are complete rewrites in specific languages. So what's the advantage of that architecture?
So
less code, I guess.
Yeah. So it's not just less code. So when we understood the problem at the beginning, we understood that we need to write a lot of clients. Like you have PHP, you have Ruby, you have like on top of what I say. Like right now we have individual contributor from the community developing client for C++ that is on top of the binding of Rust. I think it's very soon going to be generally available. Not generally available, public preview. There is also initiation of Ruby. We had already POC performance are like bypassing that the main client will be by, I don't know, 50-20%, something like that, which is amazing result. So the idea was that we are going to develop a lot of, like we need to support and give solution to a lot of different languages. So we can write everything in each language.
Yeah, a few weeks ago, I had the director of the SDK team at AWS in this podcast, and we're exactly at the place where you are now. And he was saying we are supporting 13 different programming languages.
Exactly.
That's a lot of effort. So you have obviously the same type of challenge on your team.
Exactly. So what we this, and when we had those problems with clients, with customer using clients, every time we needed to dive into new code base
specific
and understand the problem in this code base and give the solution. So with that in mind, we understood that we take the best language that we think that is for this project. We build everything in this language. Then we can develop everything very fast. We can deliver fixes, we can deliver features, we can deliver everything in one place, make it make all the effort to make it perfect in one place, and then use binding in the languages in order to create something idiomatic for each language, and with the features of each language, with everything that a developer of the language want to have. But for us, if we want to deliver a feature, we write it in one place, and then we just write a little bit of code in each language, and then it's very fast out. So it's give us the ability to move very, very fast forward, delivering feature very fast. And if you find a bug, it's very easy for us to track where is the bug and fix it, because there is no billion of code bases. There's just one.
And most of the time, I guess the bug is in the core, it's not in the bindings. The binding is a thin wrapper, as you mentioned.
Yeah. That's true. If the bug is in the wrapper, it's very easy to fix because it's very thin. If the bug's in there, we know very good the code base.
And it will be fixed for everybody. In one shot. For all the developers in all programming language. What is the requirement for a programming language to bind to Rust? It's just to be able to bind to C code, because at the end it's a binary.
Yeah, you get it as a binary
library.
We use two different methods. It's depending which language. I don't know how technical should I go, so you tell me if I
try. If it is too technical.
No, I don't know. For some reason, some people it will be technical. For some people, no. But we use we create every time that we start a new language, a new binding. We test the different option. The option that tries as the best generally are using FFI, which is a foreign function interface. Yes.
Interface.
So that's mean that you call a function that is foreign to the language from the language, but the language give interface for it, or using Unix domain socket, which means that the Rust client, the core is running in
as a separate process.
Yeah, as a separate process, and we interact from the language, scene language, connecting to it and interacting like that. For some languages, this perform best. For some languages, this perform best, and this is how we take the decision. So what you need in order to be able to bind to it is to be able to use Unix domain socket, which is pretty much every language, and to have FFI to Rust, C, C++. It doesn't matter. It's at the end, it's a binary code, so it's it's the same idea. And I think most of the languages support it.
Unix socket, is it a risk of security because you increase the surface of attacks, so you can have another process on the machine that would change the communication between the language-specific binding and the core in Rust?
The socket is not a socket it's not public. It's not socket of the what we know when we say a socket of the internet. It's external socket. It's closed. It's bind to a file that just the socket can bind to it, and it has a name. Like there is a lot of security around it in order to avoid anything. And basically, if someone can interact with this socket, that means that someone is already in the machine.
And then you have another problem to solve.
Yeah, like you have a much bigger problem if someone is the machine and can control
this type of communication
and have sudo permission. So and on top of that, anyway, we have a lot of security stuff that we take. It is like in the idea, supposed to be more CPU consumption because you run two processes. But I benchmark it lately very, very heavily against other two Node.js clients, and actually the CPU is much lower.
Mhm.
I
That's
didn't
one of
get
the
a good.
characteristic of Rust as well, is to be
Exactly.
extremely performant. So I understand why you choose that programming language. So that was the introduction to my question. If you still remember the original
Yeah,
question,
let's go
no,
back.
no, but it was super important to dive into the architecture of that client and why it's different from other, and why you did it the way you did it. But back to the user experience, the developer experience. Is it a drop-in replacement for Redis client?
So that's a very good question, because we have a lot of discussion about it, and it was a major thing. It's a challenge to create a new API, because if it's not a drop-in, it's hard for developer
To adopt.
to adopt and to migrate, and it slow down the adoption. On the other side, the whole idea of this client is to create the best,
The
to
future.
fix the problem, to be the future client, to be the future, like to be another product, something new. So the decision was that we will follow the API for the best effort we can, but we will create the best of the best, and we are not gonna compromise on what we think at the end will be the best for the user in order to be close to the other client, because this is exactly the problem that we want to solve. We want to solve the problem in the other client, and we're not gonna create the same client to have people migrate to it. So it is costing in
There is a
adoption.
migration.
Yeah,
Okay.
it's we also see it. It's take a bit more time to people to adopt it. The growth, we see that it's not so fast. But when someone adopt and make this change, he gets basically something much better, and he gonna keep working with something that is much easier to work, much easier to maintain, no problem, no issue. Always there is some problem, but like the real problem are solved. We take care of everything for him. It's zero configuration. Like for special cases there is configuration, but also one of the ideas of Valkey GLIDE is that we research the best configuration for almost all of the cases, and we give you out of the box the best configuration. You don't need to have some workaround for maybe you will have connection storm, so you need to no, we do like you just need to say TLS or not TLS, what is the endpoint, and based on your case, what is the
Authentication.
stuff that are we cannot do for you, of course. Based on your use case, you need to decide what is the request timeout, because this is differ between use case to use case. But everything else, better not to touch. We do it for you.
You mentioned many programming language for which you have a binding yet, and unless I miss it, you didn't mention Rust, and the core is written in Rust, so it would make sense to have a Rust binding, or it's not even a binding; it's almost a native integration. So why?
That's very true, and we also got this question a lot of time. Currently, there is good client in Rust.
Rust client.
Yeah, and we are not worried about it, because we are not rushing about it. But I believe that in some point we're gonna release the client, the Rust client. Like we're gonna release a Rust client. There is also community talk that want to take it and make it a Rust to make it a client, like to expose the API to the user. But what we did in the core is to create something that it's not in order to create a client, but in order to create an API for all the languages. So it's built a bit different. And in order to create a Rust client, you need to create a layer of a Rust client that use the API as a client, which is not a lot of work. And I believe that it's also a thing. We working from the user backwards in most of the stuff. If it's not something that the user not aware of he needing it, which is stuff like how we deal with topology changes, we this stuff we're gonna do even if the user didn't ask for. But if the user asks for something, we prioritize it. We work from the user backward, and we prioritize what the user asks. So, so how it is work? It's work if many users. Currently, for example, the highest amount of requests are for .NET, for C#. So currently we're developing C# because this is what
that's the
user
priority.
need. Yeah.
This is how we work at AWS. We start from customer feedback, customer requests, and work backward from there. We said at the beginning of this episode that Valkey is a drop-in replacement for Redis. And you said that Valkey GLIDE is a client for Valkey. So can I use Valkey GLIDE to talk to Redis 7?
Yeah. So Valkey GLIDE is test in our CI and our local test from Redis 6.2 until Redis 7.2, which is the last open source version.
And of course, there is no guarantee for the future of Redis because
so
we don't know.
We cannot guarantee for higher version or lower version. I believe that we do, but no guarantee. I don't say anything. But if you use between 6.2 until 7.2 Redis, you can use us, no problem. It's work perfect, and the development started before Valkey, as I said. So yeah.
The advantage you mentioned for Glide so far are for the developers of Glide, having one code base, it's easier to fix, less code, performance, blah, 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 blah. Can you give a couple of examples or just one example of a better developer experience with Valkey GLIDE than a traditional Redis client? So you mentioned automatic configuration, speed, probably memory footprints. These are the one I took note while you were talking, but maybe you have a very concrete example.
Yeah. So I talk about why we took the design decision on top of stuff. Actually, when we took the design decision of Rust is for delivering feature faster. So it's also for the user. But this is something that I can talk for hours. So stop.
I'll stop you.
Yeah. So
still have like 10-15 minutes in this episode.
So for example, when we talk about topology changes, this is something that almost every client have problem with it. Topology changes means you scale in, you scale out. There
so
was
more nodes or less nodes in the cluster.
Yeah, you change how the topology map means how you distribute your cluster, like how many nodes, or you serve how many nodes, how many replica, where each slot, like where each key is mapped. So this is what I meant. This is what we meant when we say topology. So if you scale out, meaning you increase the amount of nodes, so like some keys will move from replica to replica, from node to node, different stuff will happen, and it will take time to be stable,
to settle.
Yeah, and also if you scale in, it changes. You had a failover. I don't know. You killed. You use too many heavy Lua on your server, and by mistake you cross the CPU that the server can handle, and it's a machine, so it crashed, and then the replica replaced the master. So again, there is a change. There is a change in the map. So some clients don't have any mitigation for it. Some clients have a mitigation which is just reactive, meaning when I get error, then I try to fix. So those clients usually have the mitigation of, okay, I have a problem, so I'm now gonna do whatever I can in order to fix this problem, and I will explain why it is a problem in a sec. Okay, in this decision there is a problem. In this decision there is a problem. Okay, what we can do to solve it? And we have iteration. With those iteration, each, like we have when you connect to your cluster, to your server, we get the topology of the server, we save it as a hash, and then once in a while we ask your some of the nodes. We don't ask everything because it costs. We don't want to. So, but every once in a while we ask few nodes what is going on with the thing, and this is like we ask them, okay, do you agree all of you on the same picture? Like, do you all agree on the topology that you say? Because let's say one of the node was disconnected from the cluster, which
you
happens
might
sometimes.
have a split branch scenario.
Yeah,
as
exactly,
well,
split
like
branch. Yes. So we see if they all vote, like the most vote. It's democracy, like they all vote for the most vote for something, the same one, and then we update the topology based on it. If there is a problem, we get a move, which means a move error, or we get a node that say you can't connect. We understand that there is a change, so we start to ask, okay, what happened? But when we do it, we don't block your process. We do it on a side process. Like there is a side task in Rust. This is also one of the thing in that.
The advantage of Rust.
Yeah, there is a side task that try to fix the situation. Meanwhile, you can keep working. We don't block your main work, and we try to fix the situation, whether it's a node that disconnected or whether it's new topology. And when we try to, this is what I say, I will say soon the problem, when we try to understand the new map, because there were a change, if you do scale in or scale out, the changes are taking between seconds to minutes, because if you have a very, very big client and you move slot after slot after slot, it means that every few seconds there is another change, another change, another change. And this is what happened in a lot of clients. They get another change, so they try to get it. And another change, they try to get it. And we understand that this is what happened. So we have some kind of rate limiter that we built internally. And we say, okay, if you send a message, you said a request a few seconds ago, and then you got another move, and you said, like, don't overwhelm. What happened in a lot of scenarios is that this is a critical time for the cluster, because he need a lot of resources to make the changes, especially if you have a very big cluster.
Yeah, you don't want the client to overflow the cluster on top of that.
And if it's a big cluster, the response of what is the new topology is a big response. What happened in a lot of clients is that we saw that they make the cluster get into 100 CPU because how much they try to get the picture. So we have a rate limiter. Okay, we say, okay, right now there is changes happening. Okay, we're gonna ask once in a while.
Let's throttle ourselves a bit to not overwhelm the server.
Or if there is a disconnection, the node is not throwing, and we try to create another one, or we just move it into a recovery state. That's what we call, and there is the multiplexer that take care of it in a side process. Again, we don't bother your main process. You can keep working, but we putting one connection in a recovery state and doing it carefully without creating a connection storm. Yes, okay, I got it.
Indeed, you can talk about that for hours. I still have two questions, and we have less than 10 minutes left. So one question is, what does it take for me as a developer to get started? I go to the Valkey GLIDE website. I guess there is a README documentation there. I download the library. Code samples. Is there a migration guides?
Yeah.
What's the experience?
Yeah. So that's very important. You can go into even Valkey site, and in Valkey site you go to client and you will find the Valkey GLIDE, but you have the repository of Valkey GLIDE. You go to the repository. I hope you can link it into
yes,
the
of course, it's in the app.
Yeah. So you go to the repository. There is a wiki with examples, with how to start, with all the important concept. There is currently sites for Node.js and Python with all the API, all the documentation. I hope that when you hear it, there is also for Java and the other. No promise, I cannot end it. And there is also migration guide. Now we work on more, but currently there is a migration guide from Redis to Valkey Java, but it's under process to create more migration guide.
In other
And
languages.
Of course, there is examples, there is easy. Actually, if you create an Elasticsearch server, you will get like in the console
sample code
for Glide. Yes, exactly. You can choose your language and then it will tell you this is how you connect, and it will actually put your endpoint and everything already inside.
I love when the console does that because it's friendly. You copy paste the code and then you're ready.
Exactly. You can start.
What's next? You explain where we are today, supporting Valkey 8. We are not disclosing roadmap, even if it is an open source development. But what are the key trends for the next year?
So, as I mentioned, there is all the clients that we support. And there is a lot of features that we want to add. We want to add client-side caching, which we started to work on. In the next release, we're going to release a lot of new feature. For example, telemetry. We already have client stats. And I mentioned the new languages, and there is a lot. Like, there is a lot of features. Actually, if you listen to it and there is something that you're interested in, as I said, we work from the user back. So open an issue in GitHub or open an issue in AWS if you are a customer of Elasticsearch, but it doesn't matter. We listen to GitHub the same. Open an issue in GitHub and we will answer. Probably, I cannot promise, but probably in few hours you will already get an answer. Normally I answer in less. And this is how we prioritize things. So we want to hear from you and we want to know what you want. We want to know what will make you happy and what will be better for you. So please connect, say. And so as I said, C# is the main thing for the next few months. The next language cannot promise, but I think it's PHP. But again, it depends what user will ask. So please ask. And also maybe Rust. And it's also a lot of we are connected very strongly to Valkey. Okay, so we are working with the Valkey team together. We have meeting together.
You're part of the
we're part of the organization.
Elastic Cache team, and some as you explained at the beginning, some core member for the Valkey project are working for AWS. So but currently you support 7.2 and 8.0 on Valkey and 6.2, 7.0, 7.2 on Redis.
Also 8.1 that just went out. Yes. Okay. But if when you listen to it, there is a new version, we support this version.
We will support it as well.
So, for example, the usability feature that was released in 8.0 of Valkey, we were ready with AZ Affinity before it was released because, as I say, we are connected to them.
Working together.
So we know before, we prepare the code and so it's released.
The client progresses as the server progresses.
Exactly.
It's not a reactive thing. So, they had something, so we need to cover that. No.
But as I said, my vision is for the future, if I talk big, is not to be a connector, but to be another arm. So it means we want to be the best, and we want to be much more than just connector. We want to bring another functionalities, another abilities for you when you use Valkey or Redis, or maybe we'll support, which is also something that we consider and depend on users to support other cache or in-memory solutions. So we want to be like another arm of it. We want to be something that will enlarge your abilities and your capabilities with those products. So if I need to say what is for the future, this is for the future. It's very wide, but this is for the future.
One word to convince developers that are listening to us to switch to Valkey GLIDE today?
One word.
Or one phrase.
One phrase is that we are the most reliable, the most stable, the most scalable solution that you can have with the best vision that you can have.
Avi Fenesh, your SDE in the Elastic Cache team and one of the lead on the Valkey GLIDE project. Thank you for answering my question with your very clear and passionate point of view around this client library, multi-language client library for Valkey. Thank you for having listened to this episode until the end. Go try Valkey GLIDE today if you're using Valkey. But now, go build.